friends, welcome to this electrical engineering knowledge sharing channel AMP Power System. We are discussing about the switchgear circuit breaker control schematics. As we have said already that there will be 8 or 9 session or videos on this workshop. We have already completed 2 videos on this. One is a basic parts of the switchgear control schematics. Then we have discussed about the circuit breaker closing schematics. And on the circuit breaker closing schematics, I have received few comments from some of my valuable friends. They have highlighted that circuit breaker closing command is a temporary command or intermittent, it is a short time command. So how that short time command, it is not the continuous command, so how that is maintained. So this was not captured in my video because that video was made in a simple form to understand the control schematics. It is actually another part of the control schematics of the closing circuits, which prevent lot of other issues, not only the short terms. So as I received the comment from our valuable friends, so I thought to highlight this point by another small video so that it will be more clear. This part of this schematics, that is whether the command is a short time commands or it is in a small short time means it is a tangent commands given in a breaker instantly and the breaker get closed. Then whether the command is maintained or command is disconnected, that part actually we to capture this part more significantly, we discuss this part as a anti-pumping circuits or anti-pumping features. If circuit breaker, there is one feature in the circuit breaker, this is inbuilt inside the circuit breaker enclosures. You cannot get access to that. You know, the circuit breaker, when the making and breaking is taking place, it is inside a closed chamber. Inside that, the circuit breaker, this anti-pumping device, which prevent that continuous maintaining the command, closing command, which is preventing the continuous maintaining command, closing command, is done through a circuit called anti-pumping circuit. That is a inbuilt with the breaker itself. That is inside the breaker chamber. So you will not get access to that circuits, and this circuit connection to the outside of the chamber is getting connected through a pins. Number of pins is coming through this. Through the pins there is a plug. This is the plug and pin and plug arrangement. When the plug has a multiple pin, when I put the male part of the pin inside the circuit breaker body, there is a plug. So this get engaged, and on the back side of the plug, the wires are connected. So you cannot get access if there is some problem with this device in the breaker or those preventing continuous command arrangement. Then you need to open the breaker chamber, which is difficult. So these all are connecting through a pins, and that pin also only has a accessible. So that we discuss separately. So this anti-pumping device which we are discussing, actually what it is doing, it is one of the things is important that what our friends are addressed, that it is not allowing to maintain a continuous closing command. That is one part. Second part of this is also preventing, sometimes we do the synchronization. During synchronization, in case of manual synchronization, we close the circuit breaker by observing the synchroscope. When the synchroscope point is coming to the 12 point, immediately we can close. We generally give the closing command. That means there is a circuit breaker closing switch. The close neutral switch is there. We have mentioned that neutral close switch. That close switch, when the synchroscope point hands is coming to the 12 position, immediately we close. That is the normal practice. But if you are more smart, you may think, okay, I may miss that 12 point, so let me hold the switch in advance and keep it hold. So when it will come into the 12 position, immediately it will be closed. That is not the right way. It can happen that at 12 o'clock, when the hands is on the 12 o'clock on the synchroscope, it is in synchronization, but it is not actually this. The two vector is continuously rotating. At that moment, two vector is in line. Again, it shifted. Immediately, it is getting shifted. So if you maintain the closing command that way, if you hold the switch continuously, then what will happen? It will close, and then as it is a closed on actually system is not synchronized, but the pointer is passing through the 12. immediately it will get the closing command, then breaker will trip, but as the system is not synchronized, so what will happen? Immediately breaker will trip due to unsynchronization. Okay, so that is a very wrong operation. In that case, we can put the system in a big risk. So we do not do that. So that's why there is arrangement in the circuit breaker itself. Even you try to do that, even you try to be smart, so that smart, and you are thinking, if I keep the switch on in advance and keep it hold after crossing the 12 o'clock, then my operation will be all right, but that will not be there, and breaker will not allow this thing, because that protocol, that safety protocol is already inbuilt within the circuit breaker, and that is called anti-pumping circuit. Because in that case, why it is called anti-pumping? You close the breaker, immediately due to its asynchronization, it will trip. Again it will get closed, again it will trip. So tripping, closing. If you maintain the closing command, tripping, closing will be taking place. As it is a tripping, closing taking place, that's why you call it a anti-pumping features. So this is one of the things. Secondly, even on not on synchronization, suppose there is a fault in the circuit breaker and you close the breaker. Okay, the moment you close the breaker, due to the fault existing, breaker will trip. Again, if you maintain the closing command, then the breaker will be, same thing will be happening. Breaker will close, then on fault it will be tripping. Again, as the fault is maintaining, again you close, again it will trip. So this closing tripping will take place. That is called pumping arrangement. So that's why, to avoid this thing, we incorporate inside the breaker one arrangement, so that it will prevent this type of arrangement, this type of closing opening arrangement. As well as if you maintain the closing command continuously, because the breaker closing coil is not a continuously rated, it is a short time rating. So you cannot send the current through the coil continuously. This high current cannot send be continuously. So that's why this is a short time rating coil. It cannot carry the continuous rated current continuously. That's why we have the arrangement. The moment breaker get closed, immediately the current flowing through the coil will be cut. So the current cannot flow through the coil continuously. So that arrangement also incorporated within this feature, and this feature we call anti-pumping features. And that is done through a relay which is called anti-pumping relay, that I have already discussed. That this anti-pumping relay, we call it as a 94 relay. There we have discussed already one relay called trip circuit supervision relay, and this relay we call is a anti-pumping relay. This anti-pumping relay we tag as a 94. 94 is the anti-pumping relay. So there is a relay inside the circuit breaker chamber. That relay is called anti-pumping relay. So discuss this feature, how it is inbuilt. I have drawn the circuit. I have not drawn the top part. Top part is already, we have seen how the closing circuit was connected. There is a positive supply. From there is a switch. Local remote selector switch was there. This is a local, this is a remote. And then if you select in the local position, then it will come in from there. There is a disconnector interlock over here. Then it is going to the, we show like this. Then there is a closing coil. We show in that way in the second last video, where we discussed about the closing schematic. Similarly, from the remote position, we have a various remote command, multiple remote command over here. Yeah. And then from the command, there is a disconnector interlock, and then it is going to the closing coil. Whereas interlock is there is a permissive command is also here. Then it is going to the breaker closing coil. This way we have shown this thing. So this part now we are showing in details. Okay. So here I have shown for simplification this local remote selector which is in this location. Okay. So you can select either local or remote. Suppose this is the local position, then you are giving the, here is your local remote closing. Here you have a, in this position, after in selecting local, then you have a close, neutral, trip switch, close, neutral and trip switch. Here is one switch. That switch is, I have shown as a simplification as a push button. So this is a closing push button. Okay. It is a part of this selector switch which I put in the close position, means breaker will be closing, and when I put in the trip position, then it will go for tripping circuit. So this is a closing command. You give into the closing command. After closing command, there is the interlock over here. That is a disconnector interlock. That is over here. Then it is going to the closing coil as per previous. Now inside this closing coil, this is inside a chamber. Inside the chamber, this circuit is maintained. This is your closing coil, and this is the anti-pumping relay. So how it is working, this we have shown over here, but this other part we have not shown. So how it is doing, here we have used two contact. One is a 52. Generally circuit breaker is a tag as a 52 is a circuit breaker tag. When you say 52 means immediately we will mention, we understand it is circuit breaker. Now circuit breaker is a two type of auxiliary contact. This contact is coming from the close position and trip position. This is not the service test position. We are not discussing about this. Breaker has an auxiliary contact. Some of the contact, this contact has a two type. One is NO contact, one is NC contact. The NO contact means when the circuit breaker is open, the NO contact is open. And NC contact means when the circuit breaker is open, this is a NC. This is the, but whenever the circuit breaker from open position to it go to the closed position, immediately it will change over. 52B will become 52A. 52B we mention the NC contact, and 52A we mention the NO contact. It is a circuit breaker auxiliary contact. This contact change over when circuit breaker from closed position to open position goes to closed position, or from trip position it goes to the closed position. So this is NC contact. These all are shown in the open position, means breaker is in trip condition or open condition. The moment breaker get closed, immediately this NC contact will become NO when breaker is closed, and the moment breaker is getting closed, this NO contact will become NC contact. That is the way. But this contact configuration 52B NC, 52A NO, that is when the breaker is open or trip position. Okay. So how this circuit is working? This breaker auxiliary contact, one of the NC contact is connected in series with this. This relay is called, this is the anti-pumping relay. Okay. This anti-pumping relay, how the one breaker auxiliary contact, NC contact, and anti-pumping relay, this relay has a multiple auxiliary contact. One of the NC contact connected in series, and that is connected with the breaker closing coil. So what is happening over here? The normally when suppose now this we are going to close the breaker, means breaker is in already open condition, means this contact is NC and the relay is not energized, so this is also NC. Immediately the moment you give the closing command in the local position, immediately through the interlock, power will come through this closing coil, will get energized. The moment closing coil get energized, immediately breaker will close. The moment breaker is getting closed, immediately what is happening? This contact get open and this contact get closed. You see here, this is the interlock, this is the cascaded contact, one NC, one NO. The moment breaker gets closed, immediately it become NO, and then this NO contact will become NC. Immediately what will happen? The power will come through this, and this anti-pumping relay will pick up. This anti-pumping relay, the moment anti-pumping relay is picked up, immediately this anti-pumping relay has an auxiliary contact. You see, there is one contact over here and another contact is here. This contact is a NO contact and this contact is NC contact. Okay, that is which is connected to the closing coil. The moment anti-pumping relay is energized, immediately this become open. This become open and this is already open. So what will happen? This power is cut. And this relay is already energized through this contact, but the moment breaker, this anti-pumping relay picked up, then immediately it is also NC. So when the breaker is closed, immediately what is happening? Anti-pumping relay is picked up. So anti-pumping relay picked up means as the breaker is already closed, this is closed. So anti-pumping relay is getting power. Anti-pumping relay picked up, and then anti-pumping relay, this NO contact become NC. So it is also picked up. That means anti-pumping relay is getting power supply through to this position, through the breaker auxiliary contact as well as anti-pumping relay auxiliary contact. That is, once the breaker is closed, this is the scenario. Okay, so at this scenario, how breaker is preventing, how this circuit is preventing to avoid the closing tripping, if you maintain the closing command. Now you consider this way: the moment I close the breaker, immediately I open it. I leave the push button, then push button will come back to normal. It is a spring return push button. This, if I consider this is spring return push button, means the moment you give the command, immediately it will get closed. You leave the push button will come back to normal. But if you maintain the pressing the push button continuously, then what will happen? It will close the breaker, right? The moment it close the breaker, then this will happen. The anti-pumping relay picked up. Immediately anti-pumping relay is sealed through this. Anti-pumping relay is energized. So what will happen? This contact become open. So even you maintain the command over here, as this is open, closing coil will not get power. But if this anti-pumping relay is not there, then what would happen? You see here, if the anti-pumping relay is not there, then suppose this is the breaker NC contact, right? So the moment you close the command, immediately through this contact, coil will get energized. The moment it is energized, it become open. It become open, it is fine. Then if there is a fault, then immediately it will trip and then it become NC again. It become NC, and if you maintain the command at that time, it will be again closing. So if there is a fault on the circuit, or if it is unsynchronized, synchronized closing command, in that case, if you maintain the command, then the breaker will be continuously closing, opening. But if you put another anti-pumping relay, this 94 relay contact over here, this relay, once the breaker is closed, what is required? Once the breaker is closed, anti-pumping relay should maintain energization. It should not drop. So the moment breaker is closed, what is happening immediately through the breaker auxiliary contact, anti-pumping relay is energized. But at that moment, immediately, once anti-pumping relay is energized, anti-pumping relay also energized through the 94. So this 94 relay remain energized through two parallel paths. One is a breaker path, breaker auxiliary NO contact, which is become NC upon closing the breaker. This is NO contact. So through the closing the breaker, it getting power, as well as the moment anti-pumping relay energized, it is getting power. So in both ways, it is remain power. At that time, if you maintain the command over here, what will happen? As this anti-pumping relay is energized, even on the fault, suppose on the fault the breaker got tripped, okay? As the breaker got tripped, but the anti-pumping relay is not getting tripped. You see, if you maintain the command, because this command is you are maintaining. When there is a fault, you give closing command, breaker gets closed, but still you are maintaining the closing command. Means this command is maintaining, breaker is closed and then it is open on fault, but this anti-pumping relay is remain energized, and which is causing this contact open. So closing coil will not get any power. Though breaker is open, but breaker will not get any power. Closing coil will not get any power or will not get any signal, so breaker will not close. So this way, this anti-pumping relay, this 94 relay is preventing multiple closing tripping operation, as well as inadvertently if somebody maintain the closing command and if there is a fault at the same time on the breaker, then breaker will not further close. Breaker will close on time, then on fault it will trip, it will not further close, because the anti-pumping relay will prevent that closing. As well as if somebody try to maintain this closing command continuously, which can damage the closing coil, that is also preventing by the anti-pumping relay. So these are the basic features of the anti-pumping relay, and that's why the anti-pumping relay we use in the circuit breaker. But this anti-pumping, all this device, it is inside the breaker chamber, and if you see the breaker chamber, it is inside the breaker chamber where what is happening, there is a breaker chamber, and inside the breaker chamber there is a pin arrangement. Through the pin, these circuits are connected. This pin is coming over here on the back side. It is connected on the back side, and there is a male plug. The male plug was inserted over here, and through the male plug, all this contact is going to the panel wiring circuits. That's why it is inside the breaker chamber. You cannot see this anti-pumping relay outside. So it will be living inside the breaker chamber. Okay. This is the anti-pumping device which is preventing three things. One thing is it will not allow to maintain the closing command continuously. That is number one. Number two, it will prevent the closing tripping of the breaker in case there is a fault on the circuit breaker. On fault, if we close the breaker, then breaker will trip and it will not allow further closing. Number three, if somebody try to close the breaker on asynchronous synchronization by being a very smart, in that case it is also not allowed to further closing of this circuit breaker by disconnecting the closing command. So this is the called anti-pumping circuit of this circuit breaker. It is a part of the closing circuit. These details in the last video we have not discussed, but if somebody interested to know about this thing, so this is the brief explanation of the circuit breaker. This part will be inserted over in the closing circuit. This part, this entire things is coming inside over here. It is inside a breaker chamber, and which is connected to these all are connected through the pin configuration. Okay, this is called anti-pumping circuit as anti-pumping relay. So this is about this closing command issue which was commented. So this is the brief ancillary or auxiliary video we made for understand the anti-pumping relay. If you have any question further on the anti-pumping relay, we can discuss through email or through your comment. Please look into this, and thank you very much indeed. Thank you very much.